Thanks for coming. I hope I don't need to persuade anybody in this room of the benefits of kind of consuming APIs as a way of adding capabilities to your product. But what I want to talk about is that that's kind of no free lunch, and specifically it's no free lunch in terms of the productivity of your engineering teams. With every API that you add to your set of dependencies, you kind of bring in a whole load of potential sources of friction with those APIs. So slowness, unreliable sandboxes. Obviously, David, who just spoke, articulated this very well. Some organisations are quite kind of negligent, maybe even, about their provision of sandboxes. They don't treat them as a sort of first-class citizen in their provision to developers integrating with them. And if you're building something that requires a lot of APIs, and this problem can be very acute. You can end up with significant problems in your ability to ship software. And I suspect in a lot of open banking applications, this is a particularly acute problem because generally, the more APIs you integrate with, kind of the more valuable your product is. So you're incentivized to sort of do more and more of this and create more of these problems. So I want to kind of briefly introduce this kind of categorization of APIs in terms of how they in practice get used in most organizations. Because I think there are sort of specific problems that apply to kind of different, these different usage contexts. So first up, we have the kind of new first-party API. So this is like your microservice architecture. You have a load of other teams that are in the same organization as you. They're probably deploying these services onto the same platform. And often these are in a sort of a state of flux and instability. You're building against APIs which are being changed on a regular basis. A plus side of this arrangement is that you can exert some control over your dev environments because you can bring and run your own copies of other people's APIs. But even this technique doesn't sort of scale beyond a certain point. Running 10 microservices on your laptop is probably just about feasible, but going to 50 or 100, few people have laptops that are quite up to that job. So you have this problem of kind of building and maintaining useful environments. You have even more acute problems with sort of first-party legacy stuff. So older systems that are running on like a Solaris box in a data center somewhere, or a bought product which has got a sort of high license cost. You often find these in organizations as well, and compromises tend to be made where you end up sort of sharing sandboxes, or you have kind of one test environment and that's all you can afford, so everybody has to muddle along and make do with it. And then sort of in the third-party space, you have the kind of third-party sort of public APIs, so open banking and the kind of big SaaS providers are obvious examples of these. And these tend to be sort of fairly stable, well-designed, sort of well-tested APIs, I suppose. But you're kind of throwing yourself on the mercy of the vendor to provide you a sandbox or something akin to a sandbox. Obviously, companies like Stripe and Twilio who make their business around APIs are very good at this. They'll provide you a good quality sandbox. But as we've heard probably quite a lot throughout the conference, there are providers for whom sandboxes are very much the kind of secondary concern, and they are non-existent, unstable. You have to jump through a load of flaming hoops to get to, and so on like that. And then finally, you have this sort of fourth model of API, which is like a partnership API. So you get these kind of bilateral deals done between companies, and they'll design and build an API, which is is just about these two parties interoperating. And in that case, you get all the downsides of sort of relying on other people's sandboxes, and you also get the downsides of an API that doesn't is being brought into existence just for you, and maybe doesn't have a very well validated design. So take all these things together. So out of curiosity, does this resonate? Has anybody had one or more of these problems when building software that depends on APIs? Okay, good. Glad I'm not screaming into the void there. Okay, so with that, so who knows what a mock API is? Okay, about half of you. Good, okay. So I'll try and give a very brief explanation. Essentially, it's about mimicking an API's behavior, but without sort of fully realizing the business logic and the state of the service that backs it. And the reason you want to do this is that by doing this kind of simple mimicry, API mocks are cheap to build and run and change and all that kind of thing, far more so than actually working with kind of real application logic. So that's what makes them useful. So having introduced that concept, I want to talk about a few specific stories I've heard that shine some light on this. So like I say, open banking seems to be one of these spaces where these problems are particularly acute. And there was a story I heard a few weeks ago from a senior engineer for a company that integrates with lots of mostly open banking APIs, some kind of non-standardized but public APIs made available by banks. So they have a product that as I mentioned before, its usefulness is in proportion with the number of banks it integrates with. So they've integrated quite a few, and that number's kind of steadily going up. But in order to be able to even start integrating with these APIs, they had to get an open banking license. So that was kind of 2 months of potential lead time. Beyond that, they discovered that they didn't have sandboxes in some cases, or they had sandboxes that were sort of quite wildly divergent from what they encountered in production, which meant that they could build things against this sandbox, but they couldn't rely on being able to ship their code to production and actually have it work the way they expected. And this, in a few ways, the specifics of the security protocol, field formats being used differently between implementations, and optional bits of the spec being kind of implemented in the sandbox but not in the production system, and vice versa, all the kinds of problems that they encountered. But they use mocking very effectively as a way of solving this problem. So they managed to get enough information about the first set of APIs they were using even before they got their open banking license. So they were able to build a set of mocks they could start building their product against, kind of while they were, in parallel with trying to gain their open banking license. And by observing, once they got the license and could actually kind of observe production traffic, that meant they could fine-tune these mocks in a way that made them more accurate than the sandboxes they were being given by these banks. And that meant that they could start testing reliably against something and shipping to production with some confidence. And having the mocks around continued to be kind of a huge convenience in terms of kind of developer throughput. They're faster and easier to work with than an array of potentially sort of unavailable and unreliable sandboxes. So they continue to maintain them even for banks they've already integrated with. So that's kind of story number one. And then similarly, there's another company I spoke to, a customer of ours, who were working in this kind of partnership API arrangement. So they needed to exchange data that was kind of outside of the open banking spec with a bunch of banks, and they made these bilateral deals whereby they could push sort of enriched data into people's banking information. And they started with this problem of these APIs were agreed, but they didn't exist, and they had a product to build, but nothing to kind of test it against. And likewise, the designs that they arrived at with the banks they partnered with had to be kind of evolved and validated. So they built mocks sort of in tandem with the banks that they partnered with as part of this design process. And by starting to build their product against the mocks, they could kind of validate the design, before it had been committed to too heavily on the banking side. So there was this kind of tight feedback loop whereby, the mocks provided sort of an early warning of, flaws in the design or, areas in which it was lacking. They were also really into CI/CD. So one big advantage of using mocks is they tend to be a lot faster and, as I say, a lot more stable than your typical sandbox. So if you're doing kind of full runs of integration tests on every code commit, then running mocks can get your build time down enormously. So they were doing that. They were kind of running their entire suite of integration tests every time, and doing it in low numbers of minutes rather than the hours it potentially takes when you're running against kind of full-blown API implementations. So hopefully I've kind of persuaded you of the sort of value and efficacy of mocking. So I was going to go a little bit into kind of how it works in practice for those of you that haven't come across the technique before. I think I kind of explained it earlier, but it's essentially this process of substituting. If you've got your app and it's talking to an API endpoint, then you're substituting the API endpoint for your mock API endpoint. But then you're sort of mimicking the URL structure, headers, query parameters, all of that kind of stuff being exchanged with the client in such a way that the client doing the calling, as far as it's concerned, it's still talking to the same API. And that allows you to define exactly the behavior that you want the mock to exhibit. You can also kind of do it this way. You can proxy through the mock server, and the mock server will kind of decide whether it needs to just forward the traffic onto the real thing, or substitute for a stub response. There's a number of ways you can define mock API behavior. So it's generally, as I say, in your best interest to keep everything as simple as possible. You know, you want this thing to be sort of cheap to create and maintain, and have as little overhead as possible on your development process. And there's a few different ways you can kind of achieve this depending on the context. So one, like I say, if you're in this position where the API doesn't exist yet, or maybe you've been this is another thing that happens sometimes. There's no sandbox at all. There's no way of kind of getting it real traffic, but there is like a Word document with a bunch of examples in it. Just going and knocking something up manually by literally pasting things into forms is sometimes the best way of doing this, and it's very quick and easy to get started this way. Open API, I'm sure all of you know what Open API is and have some familiarity with it, right? Obviously it's an API description language, so there's a very natural mapping from that to kind of a simulation of the described API. So WireMock does this, WireMock Cloud does this, and it works well when you've got a sort of a good quality detailed Open API description. Needless to say, the quality of the output is a function of the quality of the input, and if you have an Open API description which is very sort of vague or open, or doesn't really doesn't provide a lot of detail in schemas, then the output you get probably won't be hugely useful for testing. But it can be a good way of scaffolding a mock API, even if it doesn't kind of get you all the way there. You can use record and playback, which is essentially observing traffic flowing through. So you set things up in the proxy arrangement I showed you earlier, and the mock server will convert captured traffic into a mock API. It's a great, really fast way of getting up and running, but kind of without really needing to sort of know the nuts and bolts of how mocking works. The main downside of this can be that it will end up being a bit of a millstone around your neck if the target API is changing rapidly. So if both the API design and the data in the target API is changing rapidly, then you find yourself constantly having to invalidate all of your the mocks created and having to redo them. You can do programmatic mocking. So WireMock, the open source version of WireMock kind of started out this way. This was its sort of original use case, essentially being able to do this kind of like just-in-time creation of mock API endpoints. And if you're naturally into sort of automating heavily as a team anyway, this can be a great way to work, sort of putting the essentially the requirements for the test kind of close to the test case itself. It's an easy way of doing sort of bulk creation if you want to run a load test against mocks, which is another really great use case for mocks when you don't have particularly good sandboxes to work against. So you can do kind of bulk creation of data via scripting in this way, which is obviously far easier than clicking it in manually. And it's good for you can do sort of additional bits of verification as well. So you can do kind of after the fact, set up a mock, do an interaction, and then verify afterwards that the data sort of pushed back out again was, conformed to some constraints. So this can be a very powerful tool. I guess the other thing this is good for as well is for highly unstable APIs, because you can sort of programmatically construct a model of the API that you're coding against, and then when the API changes, you kind of change your, the model in your code and regenerate everything, rather than, having 400 recorded stubs that you now need to delete and sort of redo from scratch. And finally, I want to mention this sort of emerging technique of using contract testing in combination with mocking. So, how many people have heard of Pact, the contract testing tool? Okay. So Pact is obviously the most well-known kind of tool in this space. The Spring Framework's contract testing tool is kind of a strong player in this area as well, and they both have plugins that will essentially emit WireMock mock APIs kind of as they're running a contract test. So it's a little bit like record and playback, but with the advantage that you're doing all this validation as you're going, throughout the recording, and you can kind of choose to keep your mock API generated if all of your contract tests pass, and then kind of throw it away at the end if not. So I think this is something we're going to start seeing more of, particularly now that I think, Pact in particular, the quality of the tool is improving very rapidly at the moment. So I think this kind of approach where you're kind of doing validation and mock generation at the same time will continue to take off. That's kind of about it for the overview of mocking and its benefits. I'm hoping these are the two things you'll take away, if nothing else, from this, which is that mocking will help you with your team's productivity if either you've got sort of unstable, flaky environments caused by other people's sandboxes and other people's environments, or in the situation if you're building against APIs that don't exist yet, aren't finished, still have some work to be done on the provider end. That's kind of about it. I'll quickly talk about who we are as well. So we make by some measures, the #1 open source API mocking tool. It's been around for about 11 years, and it's sort of quite widely deployed and used. And we also make this kind of cloud version of it. This is our commercial offering, which is aimed at sort of teams and enterprises, and gives you kind of collaboration tooling and hosting and this lovely UI. And that's about it. Thank you. We have a booth, by the way, so if you want to talk some more, please come and visit us. Thank you.